Good evening, everyone. Welcome to another Full Sail webinar. My name is Priscila. I'll be your host tonight. And today with me, we have Professor Ahmed Al, course director at Full Sail University. He is PhD in Business Administration, specialized in computer and information security. Also, Masters of Science in Information Systems, specialized in computer and information security. He has 7 years of teaching experience in higher education, 15 years of IT services experience. He is the guest of our webinar today to help you understand the AI market and show you how you can improve your skills to be part of a big company. Professor, welcome. Thank you so much for your presence. The stage is yours. We are so happy to have you here.
Thank you so much, and hello everyone. Welcome to Artificial Intelligence and Machine Learning. Today lecture going to focus on discovering artificial intelligence in our daily life, how the impact of artificial intelligence. As she presented to me, I am a course director at Full Sail University, specializing in courses that teaching advanced artificial intelligence and machine learning. So, how are you doing? And welcome to this webinar. During this webinar, we will have interactive presentations, so you will have the opportunity to practice with me live, as I will have the opportunity to open, you know, some slide that you will have the opportunity to use your mobile phone to scan a QR code and to put a response to the question showing on the screen. So if I can present now, yep, thank you so much. So today we are going to talk about artificial intelligence and machine learning. This lecture focus on the different aspects of machine learning, the different aspect of artificial intelligence, and the use of artificial intelligence in our daily life. But before we start, we need to have an understanding about what is artificial intelligence and what's the definition of it. So, artificial intelligence refers to the field of computer science dedicated to creating systems performing tasks that usually require human intelligence. Advanced artificial intelligence can be loosely interpreted as incorporating human intelligence into machines. In artificial intelligence, machine complete tasks based on stipulated rules and algorithms. Artificial intelligence is the umbrella term for any computer program that has the touch of a human intelligence and encompass machine learning and deep learning. Nowadays, artificial intelligence is used in almost all industry, giving a technology edge to all companies integrating artificial intelligence at a scale. According to McKinsey Global Survey on intelligence, artificial intelligence had the potential to create $600 billion of value in retail, bringing 50% more increment value in banking compared with other analytics techniques. In transportation and logistics, like UPS and Amazon, in transportation and logistics, the potential revenue jumps to 89% more. If an organization uses artificial intelligence, its marketing team can automate mandate and repetitive tasks, allowing the sales representative or the marketing team to focus on more relation building, lead generation, and different type of tasks. In a nutshell, artificial intelligence provides cutting edge technology to deal with complex data that a human being cannot handle, like calculation and analytics so fast. Artificial intelligence automates redundant jobs, allowing a worker to focus on a high level, value added skills. When an artificial intelligence is implemented at a scale, it leads to cost reduction and revenue increase. The global artificial intelligence in a market today had 13.51 billion in 2021, and this are expected to grow from 13.51 billion in 2021 to 17.46 billion in 2022 at a compound annual growth rate of 25%. So 29%, 0.25. The artificial intelligence in marketing is expected to grow up to $48.91 billion in 2026 at a compound annual growth rate of 29%, 0.38. So before we can jump into more, I want you to practice with me, if possible. There is a QR code in front of you guys. Use your phone to scan that QR code. The question will show up for you, and you will be able to answer the question, will robots take over the world or not yet? So yes, no, or not yet. Join us if you want. If you don't have a QR code on your phone, you can go to slido.com and you just put that number in front of you, and it will take you to the active poll that I'm going to use. I'm going to give you a couple of seconds, then we will proceed into the following slide. I'm going to participate with you guys.
I'm very curious. Yeah, me too. I want to know the truth. I'm very curious.
The point is, I know the truth, but it's hard. I know the truth.
That's
okay. So I will need from you odd numbers, more odd numbers. 33% is with like three options. 33% is in between. I need more participants just to to break this odd or even number between all of the three options. Come on, one more. Okay, so 50% of you say yes, robots will take over the world. 25 say no, and 25% say yes, but not now. Robots aren't taking the world yet. Okay, not yet. PwC predicts that by mid-2030, which is 7 years from now, up to 30% of jobs could be automated. CBS News report machine could replace 40% of the world workers within 15 to 25 years. While the advancement in technology will contribute to the growing number of jobs lost to automation, one thing that is certain, that there are still many industries and workflow that need humans. Remember one thing, we create artificial intelligence, we create robots, we create machines to serve us, okay? What we need to do is to build or replace the job lost to machines into individual who can create artificial intelligence, because this is what we call it a demand in the future, or technically near future, really like a couple of months, not even years. Some example of artificial intelligence used in our daily life. For example, and that's just an example, videos on Facebook, Instagram, TikTok, showing to you because you showed an interest in the topic. You may searched before in the past, liked or commented on such video one day, or technically you just spend more time swapping between videos. So technically, if you are like, that's your base right this moment, and you stop for a couple of seconds, then you went more, you showed an interest in these couple of seconds to the application that you're using, that you're interested in that topic, more and more videos of the specific exact same topic will show to you from the same creator or from different creators, but same exact topic going to show to you. You showed more interest. Okay. Netflix, for example, recommends movies and TV shows based on historical data. Maybe you have seen such a movie before or TV show, or just showed an interest, like you went to comedy and you saw like part of the movie and you didn't like and you went out. Next time you will have more videos to show. If you completed the full movie, more similar movies will show. Why? You showed an interest in such topic. This apply on similar application or website. A typical machine learning task are to provide recommendation, taking Netflix, for example, Netflix recommendation of movies or series based on user historical data. Now we mentioned
Professor, let me interrupt you for just 1 second, because I have something very in my mind about Netflix. Sometimes I have the feeling that they are wrong with the indications of movies. How can they change that? Because for me, for example, I just see movies about shootings and people getting killed, and I would like to see something else. So how can we, I don't know, start from zero, another account?
You should show interest in the other topic. So technically it will start showing both until and you will see it when we will talk about deep learning and building the module of machine learning. It's taking your results and processing as what you want. That's the prediction. But when the false start showing that you don't like this anymore, what's happened? The machine will learn that you did not like this topic and will start switching, giving you other recommendations later on by itself without any input of a human being.
Oh, nice.
You'll
I'll
see
try
it in
that.
a few. That answer coming in a few. Okay? Because we will talk about how the machine learns from the outcome. So, subfield of artificial intelligence, we have machine learning, deep learning, natural language processing, expert systems, and fuzzy logics. Just let me go back to my slides. I cannot see it. Okay. So machine learning is the art of studying algorithms that learn from examples and experience. Machine learning is based on an idea that some patterns in the data were identified and used for future prediction. The difference between hardcore rules is that the machine learns to find such rules. So in other words, we will not have a programmer to program our logic. The machine will program the logic for us. Deep learning is a subfield of machine learning. Deep learning does not mean the machine learns more in depth or have more knowledge in depth. It uses different layers to learn from data. So it will have multiple layers, and depth means the number of layers that will have in each application. So the depth of the model represents the number of layers in that model. For instance, Google LeNet model for image recognition. So we have image recognition by Google. That model called LeNet uses 22 layers. So 22 layers of different ways to learn, taking from like the input layer will take the first image, then process it on a different layer, then take the results and process it on a different layer, all the way to get the final results. Natural language processing, or what we call it NLP, and that based on a neural network, is in a group of connected input and output units where each connection has a weight associated with a computer program. It helps you to build predictive models from large database. This model builds upon the human nerve system, so the same exact nerve system this model building on. You can use this model to conduct image understanding, human learning, program speech, and all different application. We will talk about NLP in a few minutes. Expert systems, which is an interactive and reliable computer-based decision-making system that uses facts and historical data. So it's facts and historical data to solve complex decisions, making a decision that making problem. It is considered at the highest level of a human intelligence to make a decision. Now, remember one thing: machines does not have any feelings. Human can judge and can take a decision based on feelings. Machine does not. Machine work on facts, work on historical data and facts, and that's where the machine does not have any kind of feelings. And they are tough when they will come to the decisions. The main goal of expert system is to solve the most complex issues in a specific domain. Logic or fuzzy logic is defined as many valued logic from that may have truth values of variables in any real number between 0 and 1. It is the handle concept of potential truth. In real life, we may encounter situation where we cannot decide whether a statement is true or false. That's where I said our feeling coming in part. Next, we are going to talk about machine learning. Machine learning, we've already mentioned the definition of it just briefly. Now we are going in depth much more in machine learning. Machine learning is a system of computer algorithm or algorithms, let me say, that can learn from example through self-improvement without being explicitly coded by a programmer. Machine learning is a part of artificial intelligence which combines data with statistical tools to predict an output, which can be used to make actionable insights. The breakthrough comes with the idea of that the machine can singularly learn from data, which we use it to produce accurate results. So we have historical data, we will learn from it, and we will give the prediction as true as much as possible. Machine learning is closely related to data mining and Bayesian prediction modeling. The machine receives data as an input and uses an algorithm to formulate an answer. So how machine learning different from traditional programming? What's the difference between machine learning and traditional programming? Traditional programming differs significantly from machine learning. In traditional programming, a programmer codes all the rules in consultation with an expert in the industry for which the software is being developed. In other words, if I'm creating an application for health or for hospital, I will have a consultant from the hospital telling me all the possibility, all what they want, all the expectation, and I'm going to code that rules. Each rule is based on a logical foundation. The machine will execute an output following the logic statement. So if, in other words, if you had the basic programming, we can talk about if and then programming. For example, that's only one of the statements in a programming. If so on, then so on. So I had a logical test, and I have the results of that logical test, whether it's a true or false. I will have the results. So I know the outcome, whether that way or that way. Okay? This is in traditional programming. When the system grows complex, more rules need to be written. The application can quickly become unsustainable to maintain. It will be hard to fix. It will be so difficult to fix. That's why we needed to find another way by having what we call it, the machine learning. So what's the machine learning? Machine learning is supposed to overcome this issue. The machine learns how the input and output data are correlated together, and it writes its own rules. The programmers do not need to write new rules at each time there is a new data. The algorithm adapts and responds to new data and experience to improve efficiently over time. So that's the answer of, if I was looking on horror movies in Netflix, then I start looking for comedy. Why is comedy now showing more? Because the algorithm in a Netflix application right this moment adopted the change, and over time it starts changing the results of what you want. Google Maps. Google Maps, for example, using what we call it unsupervised learning to improve the user experience with personalizing recommendation. Google Maps, based on user history, Google Maps asks the user several questions on a specific location and then uses this data to help other users based on their search terms. In other words, if you go to a restaurant, okay, and you went in and you put a review on that restaurant, so they will ask you about, did you dine in or you take out? How much you spend? Did you take lunch or dinner? What's your expectation? How the food was? How the services was? Are there any parking lots? Are there any wheelchair accessibility? All of these questions that Google Maps will ask you when you put a review. And if you keep putting reviews, I do reviews a lot, you will be what they call it Google contributor, where your input will be so significant to Google because your input is much accurate. You provide images, you provide things. Next time, a user will go and search, hey, I want to have a good place to lunch, or pizza lunch with wheelchair accessibility, and you already said yes, this place have a wheelchair accessibility, and they serve pizza, your answer will show up. That's how the machine works. It will take your data, your input, as a result later on. Machine learning is also used for a variety of tasks like fraud detection. When you do a credit card and there's some fraud detection on your machine, you get a notification, or your card, you get a notification. How? Based on machine learning. Predictive maintenance. Your car tell you, hey, you need to do maintenance in so and so on thousand miles or kilometers. You need to do maintenance now, or you need to go and do so and so on, based on the historical data. Portfolio optimization, automate tasks, and so on. There's a lot. So how does machine learning work? Machine learning is the brain where all the learnings take place. The way the machine learns is similar to a human being. Human learns by experience. Like, I have 1-year-old. Sometimes I always tell my wife, let him explore this, let him fall, and now he know if he did this, he's going to learn from it and not doing it again. So human beings learn by experience. I need to build my experience. The more we know, the more easily we can predict. So you go, someone will fail in class. How? I know based on the way that someone doing his homework, this person will fail in class. So based on that, I can build my prediction. So the more we know, the more easily we can predict. By analogy, when we face unknown situation, the likelihood of success is lower than known situation. Like, if you first time experience this problem, the likelihood of you failing in it is higher than if you had this problem before, what to do. That's why we train people on a lot of things. Like, we train individual on a lot of things, so we prepare them for real situation. Like, for example, at schools we do fire drill. In case of a fire, you need to take this path. Why we do fire drill? So we can help that human to know exactly when something really happened, what they do. So machines are trained the same way. To make an accurate prediction, the machine sees an example, when we give the machine a similar example, it can figure out the outcome. However, like a human, if you feed previously unseen example, the machine has a difficulty to predict. So we already mentioned the learning phase and machine learning. So let's talk about the learning phase over here. The core objective of a machine learning is two: learning and interference, or inference. The first of all, the machine learns through discovery of pattern. This discovery is made thanks to data. On crucial part of data scientists is to choose carefully which data to provide the machine. The first list of attributes used to solve a problem is called feature or feature vector. You can think of a feature vector as a subset of data that is used to tackle a problem. Let me stop over here and emphasize. With traditional programming, we will feed fake data, like bring any numbers just to see our logic test will be accurate or not. Over here, if you feed the machine inaccurate result, like we have a term in programming called garbage in, garbage out. So same exact thing. If you feed incorrect data, you will have incorrect prediction. So it's so important to choose data that's accurate to the machine at the beginning to build the feature vector. Okay.
Professor, one question here from Uni YouTube. The person is asking how many times a machine needs to see a new process to really learn it.
It depends whether it's a deep learning or machine learning. But however, it will start like the first false. Whenever we have first false, it will start looking for more. So if I have more, like the percentage will change. So if we talk about percentage, so I have all truth, like let me say my example is 10, and we will come to it. Let me say my example is 10 steps. I will change my result in 10. The first false, the second false, then little by little, I will start changing their outcome because I'm getting more incorrect prediction. Okay. When I will start getting incorrect prediction, that's the problem over here that the machine will need to learn. And you will see it how it will learn. The module will start learning again and again and again with every outcome. Okay. So the machine uses some fancy algorithm to simplify the reality and transfer this discovery into what we call it a model. Therefore, the learning stage is used to describe the data and summarize it into a model. Next, the inferring phase. When the model is built, it is possible to test how powerful it is on never seen before data. The new data are transferred into a feature vector each time we have a result. Go through the model and give predictions. This is all the beautiful part of machine learning. There is no need to update the rules or train the model again because the model is taking the results from the outcome again. You can use this model previously trained to make an inferring on a new data. In another word, the life of a machine learning program goes from defining a question. So I have a question about a specific thing. I want to do something. I will collect the data about that question to get the answers. I will visualize data. We have a course like data visualization. I will visualize data. Then I will train the algorithm first time, test the algorithm to make sure that the results accurate, collect the feedback, refine my algorithm, and I will have a loop between step number 4 all the way to step number 7. That will stay. The loop will stay until the results are satisfying. Train the algorithm, test algorithm, collect feedback, refine the algorithm, train algorithm, test the algorithm, collect feedback, refine the algorithm. Okay, until it's satisfying, and then use the model to make prediction. Now we mentioned machine learning, and I want just to give an idea about the subfields of machine learning. Like we have unsupervised learning, we have supervised learning, and reinforcement learning. However, each one have a different subfields. Like the unsupervised, we have clustering. The supervised, we have the classification or regression. So it's so hard to talk about machine learning in 1 hour. Okay, so I'm going to stop until here, and I will talk about something new, deep learning, because we have a question about deep learning. So deep learning is a computer software that mimics the network of neurons in a brain, the network of the neurons in the brain. It is a subset of machine learning based on artificial neural network with representation learning. It is called deep learning because it make use of deep neural network. This learning, it can be supervised, semi-supervised, or unsupervised at all. Deep learning algorithms are constructed with connecting layers. First layer is the input layer. The last layer is the output layer. And all layers between is called hidden layers. The word deep means the network joins neurons in more than two layers. So we have at least two in between, hidden. Each hidden layer is composed of neurons. The neurons are connected to each other. The neurons will process and then propagate this input signal. It receives the layer above it, strengthen the signal, give the neurons in the next layer depending on the weight, bias, and activation function. The network consume large amount of input data and operate them through multiple layers. The network can learn increasingly complex features of data at each layer. So let me ask you another question. Can we trust machines? I will be the first. I want to be the first because this is so important.
Oh, I want to participate again.
Yeah, so important. I love this. See, that's my answer, but however, I will give you a real thing later on. So, can we trust machines? Come on, because your answer will build the later slide. So, I'm waiting for you to give me the later slide. Come on. Cooperation. Oh, two, no, that's not good. Okay, let me go into. I will take no. So if we don't trust machine, let me ask you this question: did you use it today? Did you use any machine learning? Did you use, for example, NLP? So what's NLP, and did we use it?
Yeah, I did.
You use
I
it
use
today?
my cell phone. Oh, I use my cell phone the whole day.
Yeah. So let's talk about natural language processing. Did we use it today? Have you used it today? Do we use it in our daily life? That's what we are talking about. We use systems like Siri, Google, Alexa to call someone, to remind us about something, or even to do a task. How many of us has the word or build smart homes? Do you have a smart home? The entire thing around is smart. Entire thing. So do I use it? Yes, I use it. Do I trust it? No, sorry, no. So what is NLP, or natural language processing? NLP is a branch of artificial intelligence that helps computers to understand, interrupt, and manipulate human languages like English to analyze and drive its meaning. NLP helps developers to organize and structure knowledge, to perform tasks like translation, summarization, name entity recognition, relationship extraction, and speech recognition, and we have a lot we can talk about. So we use NLP, we use machines a lot. One more thing in machines that we need to talk about also going to be chatbots. Artificial intelligence chatbot is a software that can simulate a user conversation with a natural language through messaging application. So you call or someone call you and you are talking with that individual, and then you realize that this is a machine. It's a preset. Okay. Or you go online and you're like asking about how to pay my bill, and technically it answer you. So that's a chat boot. So a chatbot is a software that can simulate user conversation with natural language through messaging application. It increases user response rate by being available 24/7. You cannot have an individual available all time. That's why you need to use chatbots. A lot of our organization uses chatbots on their websites. So whenever someone walks to their website, there's someone who will respond to them. Like immediately, someone will pop to you, and if you have a question, I'm here. Artificial intelligence chatbot saves your time, money, and gives better customer satisfaction. So save the time for you as a user going online anytime you want, and for the organization to have a better customer satisfaction. Chatbot uses machine learning and natural language processing to deliver near human-like conversation experience, whether it's voice or by chat, by text messaging. Several companies now using chatbot because they want someone always online for a new customer or to direct existing customer to support if needed. Chatbot answer a specific question or follow a specific path. Now let me ask you a question. Can I or you can you build an artificial intelligence or a machine learning program? And how advanced can we have it? Can I create such program where I can predict the age of someone, the mood maybe, the gender based on the opening video? And how advanced can I go much more? And that's for joke. Um, can I go more in advance that I can predict spirits behind me? I like it. It's the age 250 to 253. The mood is angry, gender unknown. The other one is 230 to 233. The mood angry and gender unknown. The last one is 150 and 153. The mood is very angry. Can we predict such thing? That's right. Yes. Yes, we can create that. We can predict the age of someone. We can predict. We can give the machine to learn the name. So I teach advanced artificial intelligence in the master's level students, where they are required to create such thing. This application that they will use to create this is called face detection or face detection. Then we have another one where we call it face recognition. In face recognition, I need to use 5 different pictures of that individual, saying that name is like this person is Ahmed, and give the picture. Name is Ahmed, and give the picture. 5 pictures of each individual, and immediately it will have the name underneath. I can give a prediction of the age based on how the face look like. I can even change the face. I can show the machine an object and it tell me this is a pen or pencil, or this is a cat or a dog. I can do such thing. How I can do it? We can build it by using tools, MI and like ML and AI programs, tools special for artificial intelligence and machine learning, like language using Python, C, C++, R, Java, Scale, normal programming. And by the way, The application that I just opened for you, the one that you saw that's detecting face, it's only 25 line of code in Python. 25. It's not so complicated. It's so small. 25 lines. So language we can use in artificial intelligence: Python, C, C++, R, Java, Scala. We can use frameworks like Torch or AWS. We can use library, NumMy, NLTK, PyTorch. For example, the library I used with the face detection is OpenCV, called OpenCV library. Environment like Jupyter Notebook, we can use it. Just like this. This is the face detection Python code. You can see it's so simple, and it's easy. I can do it. That's why I have picture. I cannot do it because I'm using my camera, but so easy to find faces just writing this code. So it's not complicated. If you feel it is complicated, it's not. You see over here, they are using CV, CV2, CV2. That's OpenCV. Ethical consideration with machine learning and artificial intelligence. We have several ethical issues like data security, pushing products before verification and validation, bias data, surveillance, informed consent, responsibility, safety. I will discuss some of them. Data security issues. We are using data of human being, like their names, date of birth, maybe credit card information, maybe their national identification number, all of that. If I'm not sure that it's going to be secured, this data to be secured when being transmitted through the application or being stored in the application or being worked on the application, that's an ethical consideration I need to think about. Pushing products before verification and validation. Most recent and big news, Apple, for example. Apple went ahead and released iPhone 14, and they did not even test if the camera have a problem. And immediately after 1 week, what we had a lot of people who had reported that the camera shakes when opening a specific application. Yes, they already said that they will fix it, but regardless, they push it so fast because they have a timeline that they need to meet, so they can release it in October before Samsung release in February. That's a fact. That's for sure. Bias data, profiling based on of existing data or imposing that into an actual data. Civilians, illegal or immoral civilians using medical data to perform specific health product. Another example of using smart fridge to track people food habit. You have a smart fridge. If you're at home, your fridge knows exactly what you want to eat. Now they will start showing advertisements for you of the same exact type of food. That's a ethical consideration we need to think about. Informed consent. I'm using data of people. Did I get an informed consent from them? Did they sign? Did they agree that they will be part of this data or not? It's so important to include this, because if not, this is a problem, ethical problem. If yes, then we are good. We have a lot of ethical consideration when it comes to artificial intelligence. Now, let me ask you one more question. What were your main takeaways from this presentation? What did you feel about this presentation? I will give you 1-2 minutes, then we will go to Q&A. No one? Come on. Don't be shy. I will not know you.
Come on, guys, send us.
I will not know you. We have one participating. Come on.
Typing. Come on. Just 1 minute.
Yeah.
They're sending a lot of questions on the chat. We will answer in a minute, guys. Hold on.
Yeah, well, we will start answering in a minute. Because I need to end to be able to see your chat. So, okay, let's go to the questions. Q&A.
Okay.
Any questions?
Let me just shut this screen, Professor. Let's start with, I think it was Manuela. She was asking the difference between AI and machine learning. I think you already explained, but since she asked.
We will have it much more impacting our life in the future, like really near future. Like in a couple of days, machine learning can control everything. Now we have artificial intelligence almost. We don't go out without doing something. Your car can know where you go, where you come back if you use any smart system. Your phone, if you use Google, it know exactly where you go, where you come, how much time you spend on each and every location. Even when you talk, it takes some information. There is like a security issue where they say the machine listening to you, but if you have right this moment Google like the small one or the home, there is a switch. If you turn it off for the mic, guess what? It cannot do half of the task. So you need to leave it on. That means Google listening to you 24 hours. That's also a problem. But in the future, we will have artificial intelligence controlling much more. We have it now, and it's really a lot. But in the near future, it's going to be much more.
Professor, I know that some professionals that knows exactly what's going on have some security measures, like we already saw Mark Zuckerberg hiding his camera. So it's a personal question. Do you enable your microphone, your camera? What do you think about that?
Okay. You ask a specific question. I spent 10 years of my life studying only about security. Okay. In my master's and in my PhD, I'm studying only about security. So we feel that, hey, let me protect myself. I don't do that. Let me cover my camera. Your phone, you're using it. Know exactly where you go, where you come. You trust your phone. You have pictures on your phone. Do you trust it? It can be hacked. You use your pictures on iCloud. iCloud was hacked before. We put our pictures on Google and such cloud computing systems that was hacked before. So do we trust? A lot of people don't. But when I did the study on humans, my study is about information security. That's behavioral actions, specific behavioral actions for humans. And guess what? I had people where they will walk into their workplace, and if they found someone, they will not ask them what they do. Even if that they don't know that person, they will not ask them what you're doing here. Where's your identification? They will not ask. This is truth. When you go to one place and you found someone in your office cleaning, you will not talk with them. Oh, maybe the person is cleaning, but this is the first time that you're seeing that individual. Ask them, where's your ID, right? A lot of people, they don't care, or they don't know. Now with cybersecurity, there's a lot of things. Do I trust to have my images? Yes, I put my images, but I don't trust. So that's why I have a level where I don't take a specific images, or I say something specific in a present of a mic or a present of a camera, regardless.
So it's basically impossible to hide, right? We are being followed and heard all the time. Basically.
I'm going to show you just Google from yesterday, and I will let you tell you, because I use Google, by the way.
Yeah,
That
everybody
simple
does,
thing.
right?
That's where I went today
Yeah.
in my area where I live. You know exactly how much time from
You
home
spent.
to drive 22 minutes. I took my daughters to their school, then drove another 20 minutes to take lunch. Then I traveled into my work. Everything. It's like in order. They know exactly where I
I
went,
think
what I
that
did.
I think that was a wife's idea. Some wife one day woke up and say, "I need to create that," but it's impossible to hide.
Yeah, technically it should come after me, but that's long story.
I do. I go after my husband too, Professor. But we do have more questions here, and I know that we don't have enough time to answer everybody.
Can I
Oh,
answer
sorry.
Jennifer, please?
Sure, of course.
Jennifer asked about, can we hide stuff if we use anonymous? Let me say it. Can I hide using, for example, using VPN, virtual private network? Is this security for us? The answer is no, because even if I using VPN, virtual private network, so it will encrypt the communication between my location and the other location, okay? The communication encrypted, the physical packet that's passing by my computer to the router that's for the internet service provider, all the way to the destination and coming back, this router is not belong to you. So the pinging, where the location, if you trace the packets, you can see that's pinging at so and so location, so and so location, so and so location, and coming back. All of that will not protect you. So even if you are going anonymous or you are using VPN, you will not be protected. If someone want to do a specific action, then using proxy servers will help a lot.
Thank you. Edward, he was already asking before, so I want to make sure that we answer him. He wants to know more about the time AI needs to process the training phase. He means how long, how many times we need to train a machine for.
It depends on the application. The size of the data I'm feeding it. The size of the data that I'm feeding it. I cannot predict an outcome, and I'm feeding only one scenario, right? I will have incorrect results because the percentage of incorrect results now of being failure is high. So I cannot say based on this, I will have that outcome. And that's what one of the things we said, based on historical data. So I'm collecting a data about someone in a period of time and feeding it into the algorithm so it can predict the outcome. So it's not simple process, just once and that's it. It will take time. So it's a lot.
Diana, she's asking, which is the main risk to use AI in some industries or business? There is a risk to replace human work. Yes, Professor.
Yes, there's a risk. With anything with computer, there is a risk associated. And sometimes even like when we did, I don't know, but when we do it, like I did the study on my PhD, I needed to ensure the risk associated with my study to be minimal. Okay, if it's not minimal, then we will have a problem. Risk associated, that's for sure. But do you trust that the computer or a machine do a surgery to your eye or to your heart? Do you trust that? The answer will be no. Right this moment, we have surgeries that done by machines, not a surgeon opening your eye or opening your heart, a machine going inside and out. But we don't trust it. But at the end, we are using it. There is risk associated with it. Risk will be minimized when I'm studying the entire scenario. I will study the entire thing. The consequences is more than the advantages. I'm maintaining that robot. I'm ensuring that everything's working fine. then the risk will be minimal.
Do you think that one day we'll have planes flying without the pilot?
We have cars driving without drivers.
Yes. Yes. Oh my
And
God.
technically, we have
But do you think that
autopilot.
people, as a passenger, I believe that people won't trust the plane, only if they don't know. Because imagine you're boarding on a plane without the pilot.
So the moment that a plane will reach a specific or stable in the air, they switch it to autopilot. They will not do anything. They will not hold 12 hours the steering wheel for an air. No, it's autopilot. But the scary thing, if it's like these videos that we see on TikTok that they're at home, that's scary. But regardless, we have cars driving without a driver. Like if you go to Google in I think it's LA, they have cars going around their building without any driver inside.
Yeah, and I saying she would go into an automatic car. Yeah, maybe the car, but the airplane, I don't know. I think it's different.
Let me take the advantage of it. Right this moment, I have a vehicle that if I'm approaching to the line, it will drive me back. If someone take a brake or reduce the speed front of me, it will decrease the speed. Read all of that just to make my life safe and my family safe. So I will accept it. But depending on it, it's kind of scary, but I'm pretty sure. In the United States, we have that we need to have more electronic cars by 2030. So 7 years from now, we need to have 50% of the cars to be electric. So how we will trust it, right? It's technology, and technology changes so fast. So let me complete. Oh yeah, she's back.
I'm back. It was the machine. See, we cannot trust machines. I told you.
That's the beauty of internet.
No, Professor, I have one question. Do you think that there is one thing that a machine cannot learn? Like in some industry, we are talking about replacing workers. And do you believe that there is one thing that cannot be replaced by machines?
Psychotherapy, I think, because it depends on feeling and psychology, which technically is not logic. That's my opinion. However, I want to answer Uni from YouTube. I love to have a robot to talk to walk my dogs. I have a robot that's clean my house. Small thing that go around, know exactly where to go, has a map, it mobbed it, so we're good.
Yeah, Professor, you blew my mind. It was impressive. Thank you so much for your time, for your patience, for answering all the questions. I hope we can have another opportunity to talk to you and to share all your knowledge and experience here.
Thanks so
Everyone, thank you so much for joining us. Unfortunately, 1 hour flies and we need to let Professor go now, but we hope to have him soon again here with us. Thank you so much.
Thank you so much.
Thank you so much. See you next time. Bye, everyone.